Hello. Today we will be doing a quick, easy workshop on how to make an augmented reality app for your computer's webcam using image tracking. So all that this is, if you have a picture and you want to have your camera recognize it and maybe display a 3D object over it, this is the tutorial for you. So we're going to be using software called Vuforia, and on top of that we're going to be using Unity for this. So this tutorial does assume that you already have Unity installed. It does not assume that you have anything with Vuforia. So to get started, make sure you have Unity installed. I recommend using the Unity Hub to install your versions of Unity. And I also would recommend when you're installing to have some kind of IDE or a text editor, such as Visual Studio or Visual Studio Code. So now that we have, assuming we have Unity, let's now get Vuforia. So Vuforia is our engine to allow us to kind of handle this image tracking in AR. So all we're going to do is go to the website developer.vuforia.com. You can see it up top. Let me see if I can make things pretty for you. There we go. Aha. So now when I click things, you'll see a little yellow highlight. That'll be nice. Okay. Yeah, so vuforia.com, you want to go there. And at developer.vuforia.com, you'll end up on this page. Current events may not be the same at the moment that you show up at this page, but you should have this bar at the top. So the first thing you need to do is make an account. I'm currently logged in, but if you are not logged in, you will see up here it'll say login and register. So you're going to want to click register, and you're going to want to make an account. It's very simple. You just make an account. It may ask for what company you're with. If you see that, just type in Virginia Tech, if you're a student of Virginia Tech. Otherwise, type in whatever you want. Frankly, I don't think it matters. So once you've made your account, it's going to ask you for an email verification. You're going to have to click that and get that all set up. But once you have your account, you will be able to access this tab. So I'm going to click now on Develop. So once you've made an account, you should be able to click on Develop and get to this License Manager and this Target Manager. You probably will not see anything down here. This is my license that I have right now. For you to get a license, all you have to do is click Get Basic. And I don't think it's going to let me. Oh, it's going to let me. Okay, well I shouldn't go through with this because I already have a basic. But what you can do, all you have to do is just make sure you type a name here to name the plan. All that means is it's just the name that you're giving to it so that you can manage all your different plans. Call it whatever you want. It does not really matter. And then check this box and it will let you confirm once you have done that. But I have already made a license. My license, I named my license. Alright, so we have our license on vuforia.com. And the next thing we want to do is we're going to actually jump over to downloads. So in here, you'll see SDK is selected, and that's what we want to get. We want to get the Vuforia engine. Sometimes it'll keep hitting you with these pop-ups down here. We want to get the Vuforia engine SDK. So make sure it's set to 10.5 or whatever the latest version is at the time. And all you got to do is, so SDK, blah, 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 blah. This first one, Unity, add Vuforia engine to a Unity project or upgrade the latest version. Just click on that, say you agree, and you will download a Unity package that you will be using to make this happen. So, first step done. Okay, now here's the next step. We want to, in order for Vuforia to know how to track, or what images to track, they actually have to build these databases. And as far as I can tell, a database from Vuforia is kind of like a set of images that the algorithm has run on to train so that it can recognize these images at any orientation. When we're picking an image that we want to be tracking, we want to make sure that it is completely, what is the term? There's no way that it could be the same when reflected across any line that we draw across it. So for instance, I'm going to show you a set of images right now that we can use. They have to be completely asymmetric from every single angle, is what I'm trying to say. And we want to have a lot of edges. An edge being an area between a light and dark area in the image. So I'll give you some examples right now. Right now I want you to go to, I'm going to make a new tab. I want you to go to bit.ly slash Vuforia workshop. Go there. It'll take you to a drive folder that I've shared. And in there, we have all three of these images. You're going to want to just download each of these images. It'll zip them if you download them all together, so I'm just going to download each one at a time. Come on. Download. Oh, it appears I already have them downloaded on this computer. But yes, you want to download each of these. And then once you have them all downloaded, you're going to want to go back over to the Vuforia SDK, jump over back to the Develop tab. So again, developer.vuforia.com, we're going to the Develop tab. And right now we've created a license, but we also need to create our image targets. So we're going to go to Target Manager. And we're going to create a new database here. You can see I've already made some. When we're selecting a target, as I said before, I'm going to show this to you now with examples. When we're selecting a target, we want to make sure that it qualifies as both being asymmetric along pretty much any axis that you could look at it, and that it has a lot of edges. So a great example is this one here called Stones Scaled. That's in the set that I'm sharing with you. You notice, right? There's a lot of highlights next to a lot of darks. These, literally the edges between the bright and the darkness, that's what I'm talking about when I'm referring to an edge. And there's a ton of them here. And there's no way, no matter which way you cut it, there's no way that if I cut it like along this diagonal, this side is different than this side. There's no way it could be misconstrued as a mirrored image in any way. If you looked at this image as a computer, you could always tell the exact orientation of it. So it's not that hard to make an image like this. Just take a picture of some scene with a lot of light and dark in it, and most likely it's going to be asymmetric. So yeah, and this is all you have to do. I'm giving you some samples, but if you wanted to choose your own, that is what you want to use. In some classes that may be using this workshop, you may be asked to find your own. So in that case, again, look for the edges and look for asymmetry. So we have downloaded these. I have all of them downloaded. I'm going to make a new database to put each of the images into. So to do that, I'm just going to click Add Database. I'm going to give it a name. I'm going to call it My Workshop Images. Call it whatever you want. It doesn't matter. I do believe they don't let you have spaces though. So, and make sure device is checked, and then click Create. Cool. So I have my workshop images, and you'll notice under targets it says there's 0. So all we have to do is click on my workshop images. It will bring us to this page, and you'll see we don't have any targets down here. So all we have to do is add them. I'm going to go to Add Target. I'm going to choose a file. So in this case, the ones that we have, let's choose Stone Scaled. Okay, the ones that we downloaded. And I'm going to add, let's see, we have to give it a width. So for width, all this means, and you can understand if you just read the text here, but what it's effectively saying is that in scene units, which in Unity is in meters, you want to give the size of the image. When I show you the view from the camera later, you'll see I'm going to be holding up a piece of paper with this image on it. And this piece of paper, I believe, is probably like 0.3 meters-ish. However, I don't like the usability of that. When I'm in Unity, I kind of would like to have larger objects. It just makes my life easier. And so having it so that my sheet is considered 1 Unity meter wide makes it easier for me to determine the scale of my objects. Think of it this way. If I put a 1 here, which is what I'm going to do, I'm telling it that my sheet of paper, when it sees that image on the sheet of paper, I'm telling it that that sheet of paper is 1 meter wide. But what this means is when I'm in Unity and I'm making an object, and let's say I made the object, 3 Unity units wide, I'm effectively saying this is 3 pieces of paper wide, which to me makes more sense. Yeah, these are just specifics if you're working on a specific project or something, maybe where you want a life-sized something to appear when you look at an image. You're going to want to keep track of this. So if you do want a life-sized object, I would definitely recommend typing in 0.3 or whatever the conversion is of here, 11 inches to meters. Yeah, so about 0.3, 0.279, so 0.28. If you type that in, you will be giving the closest accurate approximation for like an 8.5 by 11 sheet of paper. But anyways, I'm going to put 1 because it's going to make our lives easier in Unity, since I can just think of every object I put as, being compared to the size of a piece of paper rather than being compared to a meter. If all of that seemed like too much, just put 1 and it'll be fine. Leave the name as is. I'm just going to add it. Okay. And I'm now going to also add the rest of them. So add target, choose file, tarmac, width 1. Yeah, it's all depending on the size that you want to use. So, and finally I will add the chips. Okay, and I'll give it a 1. Add. Okay. So now everything has been uploaded. It says it's processing, but if I was to refresh, it would say it was done processing. You'll see these have a really high rating. So when you upload an image, it will rate it on how good of a image target it is. These are the examples that Vuforia provides. So obviously they're going to be 5 stars, but again, the rating is determined off of asymmetry and edges. So remember that. Okay. So now what we want to do is download the database that contains these 3 images in an analyzed form. So that's basically what's going to happen when I click this button, which you can now click right now. We want to choose Unity. Do not have it set to Android Studio or any of this stuff unless you are building a mobile app. And you'll see it's compiling the database. So what's happening is it's analyzing these images and kind of turning them into a data set so that it's just trained to recognize these images. And you'll see we've downloaded the package of the database right here. Okay, so now it's time to get these into Unity. So first things first, let's make a new Unity project. I'm gonna click New Project in my Unity hub. I'm gonna name it I don't know, Vuforia Workshop Video. Okay, and we will create the project. And now it's gonna spin up, everything's gonna take its time trying to get it all sorted out. That's just kind of how this works. Here we go. And this is going to be just a bit of waiting. In the meantime, I can cover I guess there's one thing we're going to have to ready. So while we're waiting, we might as well go over to our license manager. And when you did the get basic earlier, this should have shown up. It'll have whatever name you gave it, but you should have a tag here. Looks like Unity is still doing its thing. You're going to want to click on it, and it will show your license key. I'm not going to keep that on screen for too long, but yeah, it will show your license key. You might just want to click it right now, because clicking it, you see when you click it says copy to clipboard. So yeah, and oh, here's Unity. If you see it ask for an update, you can just click the X. It's not really that critical. As long as you're running Unity 2020, you should be set. And frankly, it'll probably work with 2019 as well. So anyway, Visual Studio package, blah blah blah. Package manager for better Visual Studio integration. Tempting. Not today. All right. Our next step is we want to import these. We want to import Vuforia, and we want to import the database that we've made. So very simple. How are we gonna do it? Just gonna go back to Chrome, and I'm gonna drag and drop. I'm gonna take this one, add Vuforia package. Actually, I believe I don't even have to drag and drop. I think you can just click it, and it will appear in Unity. Yeah, that's all you have to do. Just click on it. If it's in your downloads folder, just double click on it. It will pop up. It'll say import, and you'll make sure everything's checked. It'll always be checked, and then press import. And then it'll pop this up and ask you to update. You want to update. So we just wait a moment while it does its thing. Yeah, I'm running this off of a hard drive rather than an SSD, so you may fare better with your time waits. Yeah. Actually, did I move this to an SSD? I think I did. Yeah. Alright, here we go. So now, you'd notice under Packages, there is Vuforia Engine AR. You'll notice if you go to Window, Package Manager, that there is Vuforia Engine AR. Ignore the rest of these might not be there for you, but Vuforia Engine AR better be there. And what we want to do next is we want to import the database that we made. So once again, we'll go back. I'm going to click on the database that we got. Mine's called My Workshop Images, and it'll pop up in Unity. Just click import, and it's there. It's in. Cool. You should see this streaming assets folder up here. Okay, so we have them all in Unity. We now need to get Unity set up for Vuforia, and it is as simple as this. Click on the main camera and press the delete key in Windows. On Mac, I've heard you have to right click. Yeah, and then click delete from the right click. So we've removed the camera. You'll notice when we go to game, there's no camera left, because there's no camera to render the scene from. We're going to add a special camera right now. So I'm going to right click over here in hierarchy. If you wanted, you could also just go to game object, Vuforia Engine AR camera. In fact, I'll just do that. Game object, Vuforia Engine AR camera. Oh, I need to accept the software license agreement. So all we have to do is click accept. Okay. There's one other thing we'll have to do soon. But yeah, anyways, we have our AR camera, and we should also add our image target. That's what I was saying. In Unity, we're going to end up having kind of like a picture of the picture that we're tracking. And when the camera sees that picture, it moves the virtual picture to be in the same place as it. So all I'm going to do is I'm going to right click here. Once again, we could go to game object to do this, but this time I'm right clicking just to show you both ways. We go to Vuforia engine. I'm going to click image target. And there you go. We have an image target here. Okay. So there's one thing we have to do before we can even get Vuforia working, and that is to give it our license. So I had us copy our license earlier. Let's use it. I'm going to go to Window, Vuforia Configuration, and right here where it says App License Key, we're going to just paste it. Now, one important thing here is it says Add License. Don't click that. When you click that, it adds another license. We don't need more than one license. So don't click Add License. You're going to see the same thing happen all over the place. Add Database. Don't touch it. For some reason, the people who wrote Vuforia have bad wordings. This shouldn't say Add License. This should say Add New License. And this should say Add New Database. We already have a database here. Okay. One final thing you may want to do is if you want to have more than one tracked image at a time for a class project or something, you will want to change max simultaneous tracked images to fit the number you want. I can drag on this, or I can just type it in. I'm going to type 3 in this case. And yeah, that's all you need to do. I would recommend that you scroll down and just take a peek, make sure it says webcam here, and make sure it says something that looks like integrated webcam or 1080p, something that is a camera that you're using. I have a lot of different webcams, so this is the one I'm intending to use. Alright, so now that we've set that up, the next thing we want to do is probably, just save. I just pressed Control S. On Mac, it's Apple S, just in case anything crashes. Alright. Next, it's time to take a look at our image target. So you'll see I can select it down here, but we can't really see it. We're pretty zoomed out. So I'm going to scroll with my scroll wheel and zoom on in. And you'll see actually there's nothing to see here. We need to make it so we can see this image. Right now it doesn't have an image locked to it. So all we're going to do is click on image target. You see where it says image target behavior script. And we're going to choose change it from image to from database. Change database to our database name that we've imported. And change the image target itself to whichever one we want. I'm going to use stones scaled. And you'll see that it appears here now. Okay. We're really close. We've almost finished. All that's left is to attach something to this object. So as I said, when we hit play, when we hit this play button, it's going to track the image in the camera view, and it's going to move this virtual image to match the camera image. What that means is that if we make an object a child of this image, using Unity's hierarchy system, it will move that child with the image. So I'm gonna add a cube. I think that would be nice. Let's just 3D object cube. If you wanted, you could import your own 3D models over here as an object and use that instead. This cube's pretty big, so I would like it to be a bit smaller. Maybe 0.2. I'm just changing that in its scale properties. And also, I would prefer that it's at 0, 0, 0. That way, it's centered exactly in this sheet. But we should probably put it a little bit above the sheet. So I'm just going to kind of grab this handle and drag it until it's clearly above, about 1.26-ish above. Yeah. I would recommend putting it above, otherwise you might have some weird artifacts happening. So I've just moved the Y value up on the cube. Okay. So now that we have our cube attached to the sheet, might as well give it a demo. Oh wait, but there's one thing we're missing. Right now these are separate. I'm going to take the cube and drag it onto image target, and you see now it's indented. What this means, it is a child of image target, and whenever image target moves, the cube will move exactly the same. That's how the parent-child structure works in Unity. One other random thing to note, never ever change the scale numbers here for your image targets. That will break everything. It just won't work. Okay, so now that we have this all set up, let's do a demo. Let's do a quick demo. I'm gonna go to game view. I'm gonna switch it to maximize on play so you all can see clearly. And there may be a mic in my face. Let me grab my sheet to show you. Okay. Let's click play. And you should see. You should see a camera. Is there something bugging out right now? You should see a camera. Oh! But you don't see a camera because I am using OBS to stream this. One moment. Let me disable my use of camera. There shouldn't be a camera activated right now. Production. Okay. I'm sorry for the delay. Just need to change a setting real quick to make sure this deactivates when not showing. Okay, let's go back to this one. And our camera's off. Fantastic. Alright, so now we should be good. This is an important thing. If you have Zoom open or something, this will not work. So this was evidence. I had OBS open to record this, and it was using my webcam. So let's press play now that I have turned off OBS using my webcam. And you should see me. Awesome. So here we go. When I move this sheet up, you see there is a cube on it. Voila. Cool. We can move it closer, we can move it further. There's a microphone in the way at this angle. Yeah. And you can always change the way the cube is lit. I can see right now that it's kind of looking very washed out and white. But we can totally change that just by modifying how the lighting is working. But anyway, you can see that it tracks. Cool. So now what if you want to make it do things? Alright. Like, we can have this cube just track on this image, but what if we want to do more? What if we want to, for instance, make it spin? Alright, well, let's just make a quick script. All I'm going to do is go to Assets, and right-click, Create C# script, and I'm going to name this, let's make it spin, let's make it spin. Let's make one for spinning, so I'm going to call this Cube Spin. Okay, now I'm going to double-click on it, and it should open up in Visual Studio. It could open up in something else for you if you do not have Visual Studio installed. Your best bet might be to open it up in Notepad or text edit on a Mac, and you're just going to want to type in the exact things I type. Alright, so this is Unity scripting. I'm not going to go too in-depth here, but what I'm going to do is I'm going to write some simple code to make our cube rotate. So I want to rotate the transform of the cube. The transform is what defines how the cube, how it's positioned in space. So I'm going to type lowercase transform dot rotate, and rotate asks you to transform it by a vector. So we need to make a vector. So I'm going to say new vector 3, and now we need to construct the vector. We want to rotate, I want to rotate mine side to side, kind of like spinning around in a circle, like if I was spinning around in a spinning chair. So that would mean spinning around the y-axis, which is the second axis here. So first one is the x-axis, so I'm going to put 0. Second axis is y. So I'm gonna put, let's go like 50. How about 60? And this requires a float, so I go 0.0f to make sure that the number is a float. And I'm gonna type 0f to define the final part and add a semicolon. But there's an issue with this code. If you've used Unity before, maybe you've spotted it. Right now, we are rotating based on the frames of Unity's rendering. So the update function is called once per frame. So right now we rotate this much every single frame. That's not what we want to do, right? If this is the case, then we're going to spin super fast on a really fast computer and super slow on a slow computer. That wouldn't make sense. So good code, you want to make sure that it works the same on every computer. We're going to type times time dot delta time. And what this means, delta time is the amount of time that has passed since the last time you called time.delta time. Or I think it's the amount of time that's passed between each frames, technically, but it comes out to the same, since this gets called every frame. So by multiplying this, we ensure that no matter what system we're on, it's always going to spin the same speed. So we've made our spinning script. That's it. It's one line. Boom. All right. Save it. Make sure you save it. And then hop back into Unity. It's going to reload your script assemblies. And now we need to make the cube spin. So I'm just going to drag cube spin onto the cube. And you should see... Oop, that didn't work. Did I miss? I may have missed. I'm going to drag cube spin onto the cube over here. Boom. And you see cube spin showed up here. You could also just drag it into the inspector over here. And normally you can even drag it and drop it straight onto an object. Let me ensure that I didn't drop it onto anything else. Oh, I did. I accidentally dropped it on the camera. Let's get rid of that. Cool. All right. Back to the cube we go. You see we've got cube spin on it, and when I press run, what do we got? We've got a spinning cube. Ooh, look at it spin. That's pretty fun. Cool. All right. Now, two things. Two things are left. First, what if we want to do something more interesting? What if you want to have it look like your object is hovering? This was requested from a friend. I think I'll add this as a script. So let's add that. Let's make hover a script. And take note, I haven't done this before, so this is probably going to look rather bad. So let's go make a new script. I'm going to go to create, C# script. I'm going to call this one hover behavior. No, I don't want to use the word behavior. Just call it hover. Okay, so for hover, I guess I just kind of want to have it bob up and down. So let's open up our script by double clicking on it. And so quickly we threw together a little script here. This is technically only 2 lines, or actually 3 lines of code. We have up here you write vector original position equals transform.local position equals, and this is 1 line of code technically, but I've put an enter at different spots to make it more legible. Yeah, take this time right now to freeze the screen and make it look however you want. Note, I pressed enter after this and after this. These have automatically tabbed in to look just more legible. That's all that's going on. So yeah, feel free to pause right now. This is hover, and I will cut back out to show you what it's like. So if you take a look, this is the hover effect. It's just that the cube kind of goes up and down. It's just following a sine wave movement, but I think it looks kind of cool. Yeah. So there's two different kinds of things you could do to your cube or your object or whatever you want to have show up here. Again, all I did was just make a very simple script to make it move around. Alright, so onto the final item. So what we have to cover today. You probably want to know how to have more than one of these going at a time. So, for instance, right now we only have one image. But you remember earlier when we went to Window, Before Configuration, and we changed this number to 3? We might as well have 3 different images to track off of. So, and we can even have 3 different images and 3 different cubes. I'm just going to right-click image target. I'm going to duplicate. And I'm going to duplicate it again. You'll see under each of these, they each have their own cube. Let's kind of drag them out so you can see them though separately. I'm going to zoom out a little bit. Let's drag one over here. Let's drag another one over there. Okay, right now these are all the exact same image trackers, so these would all kind of jump onto the same image if we were to just click run right now. These would all jump. It would look like the same as we've already been looking at because there's 3 different cubes. Or because they're all the same. And they're all tracking to jump to lock onto the exact position of our stone image. But what if we want to have different images? So for instance, right now I'm going to take the cube, or not the cube, I'm going to take image target 1. Let's change its image to not be stone scaled. What if it's tarmac? And what if image 2, we change its image target to be chips? Okay. And, you know, maybe we want to tell apart our cubes, for instance, so that we can know that one of them is supposed to show up on chips and one's not. So I'm just going to go to assets real quick. I'm going to make create material blue and create material. What's a fun color? Orange? No, that would be UVA. What's a fun color? Red. Okay, and this is just a quick thing. I've made a material like that. I'm gonna choose on my color wheel. I'm gonna make blue. Oh, sorry, I want to make blue blue. I'm gonna go to red. I'm gonna click on this little button up here and make this red. This is not necessarily an important aspect. That's why I'm kind of rushing through it. But I'm just going to drag blue onto this one. Let's drag red onto this one. So now we know each picture should pull up a different colored cube, right? Cool. And maybe we wanted to track more than one picture at a time. We could have all these pictures and they'd all have their own cubes. So let's just press run and take a peek at what this looks like. Okay, so first, we got what you've been seeing the whole time. We got our bouncy boy. And now, let me pull up on my phone an image. How about the wood chips? So if I pull up the wood chips on my phone, I believe I should be able to get it to trigger. There you go. What do you know? It's a red cube. Bouncing up and down at the same time as this white cube over here. And if we wanted to change it, do we want a blue cube? Red cube's still stuck there, but now here's the blue cube. Yeah, and you'll notice that what happens is when an image leaves the frame fast enough, it leaves the virtual image behind, which is why we have 3 cubes floating in front of me right now, because they didn't get dragged out of frame by because the tracker didn't watch an image move out of frame. So they're all just stuck here. So if you see this happening, it's normal. This is just how it works. Okay. You may consider making some code for when an object leaves detection to send it off screen somewhere else or to hide it. So for instance, I can just point that out to you exactly where that is. If we go to image target, see on target lost, you could write a script here that would cover that instance. So, but yeah, that is the basics of fiducial and or image tracking in AR using your computer's webcam. This should run even on a laptop. I ran it on my laptop that has no graphics card. It works just fine. So yeah, that is it. Thank you all so much. I've been Alex Krasner from the Virtual Environment Studio at the Libraries of Virginia Tech. And feel free to come by the Virtual Environment Studio if you want to try out any VR headsets or VR games, or if you would like to work on a VR or augmented reality project of any kind. We've got you covered. So yeah, we're all up on the 4th floor of the library. So anyway, thank you for watching and have an awesome day. Peace.